Hi, welcome back. So, I want to talk to you now about experiences and how they shape the brain. There are two different types of ways that experience shapes the brain. First is experience expectant brain function. The brain is expecting to hear language, expecting to have emotional reactions and social reactions with other people. So, those experience expectant brain functions have to happen in order for the brain to figure out what culture it's in, how it's being raised, what language it will speak. So the brain is expecting those experiences to happen. Experience-dependent brain functions refers to the type of experiences that you have that develop certain aspects of the brain. So if you're exposed to a lot of music in your childhood, encouraged to play an instrument, your experience-dependent brain would then build structures that were dependent on those experiences happening. So expectant means things that are happening for everybody. The brain is looking for those in every single person. The experience-dependent brain function is the part of development that makes you an individual, that really individualizes who you are compared to other people. So some examples from language development studies. Human babies learn language much like birds learn songs. They hear their parents and other people in their culture speaking the language. Adults talk and baby brains expect a culturally specific language, and they're tuning in to figure out which culturally specific language they're hearing. So some examples from bird brains. Birds inherit genes that produce the brain cells they need to learn new songs to find hidden seeds. For the dendrites and neurons to connect, birds depend on specific experiences with song learning or seed finding. Relationships are a central context of brain development. Most brain development happens in the context of these relationships. And here you see Amelia Rose with her father, and then a graphic of how this interaction is happening between two parents. That interaction where children are watching their parents for a reaction, where there's warm, responsive care, strengthens biological system, and it helps children handle emotions. The act of touching babies, holding babies, all of those warm, responsive interactions with other people in their family help children learn how to regulate emotions and provides that comfort and development for the emotional centers of the brain. Research shows that a strong, secure connection with the child helps them withstand the ordinary stresses of daily life, not just in the moment that it's happening, but in the future. That coming to depend on that warm, caring relationship builds resilience in a child that they can refer to later in life. Face recognition. There has been a lot of experimentation with infants about how do they recognize the different faces within their families, within their communities. Fusiform face area of the brain makes the newborn and infant adept at facial recognition. They recognize human faces and prefer to look at those over any other types of faces or anything else in the room. So if there's a human in the room, the baby is tuning in to where that human is. It helps the survival instinct of the species if the infant is actually able to recognize the faces. A lot of these experience-dependent neural specializations in infancy, the experiments that they did with those, they did them with different types of apes and monkeys, and then also did other types of experiments with human beings. The experiences refine the facial perception, and they trigger immediate recognition of those people within the child's family. This has produced what's called the own race effect. Before the first birthday, this is apparent in children who have been raised in a monocultural environment where they're not exposed to different types and different diverse people in the world. And it will persist throughout life. So the earlier we're exposing children to diversity through books and literature, as well as in our environment, the more their brain will develop synapses and structures to recognize diversity as all being part of their world. The more children are raised in isolation from that diversity, the more they will have an own race bias or effect or preference that shows up prior to the first birthday. So there's some harms that can happen to the infant brain. They need stimulation. Infants need a lot of stimulation in order for those brain structures to grow. They need to play. They need to have various sensations. They need to be encouraged to move. All of those are necessary for brain connections. So infants that are kept too long in swings or carriers may not have that movement that's necessary for the brain development and motor control, for example. Stress causes huge amounts of issues within brain growth. Overabundance of stress hormones can damage later brain functioning. It can damage the building of the brain at a foundational level that affects the rest of the child's life. Severe social deprivation. There is some anecdotal evidence with human children and research with other mammals that confirms that isolation and sensory deprivation harm the developing brain. There is some unethical research done on rhesus monkeys that I believe I talked about earlier in class that showed that social deprivation actually can harm the brain to the point that the rhesus monkeys can't survive. They would either, when they reintroduced them into society of monkeys, they were either murdered or they committed suicide because they did not have the brain structures to figure out how to interact socially. There needs to be some intervention in some of these harms that can happen to the brain. Shaken baby syndrome is a life-threatening injury that occurs when an infant is forcefully shaken back and forth. The motion of that back and forth shaking can rupture blood vessels in the brain and break the neural connections. It is something that occurs typically with a parent or caregiver who's frustrated and trying to figure out how to stop a baby from crying and obviously not handling it in the right way. But I think it's so critical that we get information out to families about how fragile that brain is in the early developing years. Here is a module of the stress response syndrome. So you can see here from the hypothalamus, there's a message that goes out to the adrenal gland through the pituitary gland, and then cortisol is released, and that'll go out to the immune system and cause compromised immune system if the cortisol is released for too long. And it will also go back and become this feedback loop of stress. And again, cortisol released in the body system over an extended period of time can cause damage to the brain, the heart, and all of the body functions. This is a picture of a normal brain synapses, and here is a picture of excessively high levels of cortisol and how it affects the brain structure, making it vulnerable to processes that destroy brain cells and reducing the number of connections in certain parts of the brain. And so these are actual photographs of synapses and neurons. And you can see the difference in the clumps on one side in the normal brain and the sparseness of those connections on the stressed brain that's received too much cortisol. The early years are really important. At a child's birth, there's a lot of neurons, but not very many connections. At 7 years, you can see there in the middle, there's a lot of connections going on. The child's made a ton of connections in many different ways for every single thing they've heard, they've seen, they've experienced. By 15 years, the brain starts to prune out those connections that aren't used very often, the deer paths of the neural pathways instead of the freeways, and it'll keep the freeways. If something is used a lot, it'll hold on to that information. If a neural pathway is not used a lot, then it gets pruned between the ages of 10 and 18, usually those teenage years, the brain's doing a lot of pruning. Brain development is more vulnerable to environmental influence than we previously thought. There's a huge vulnerability to what children experience socially, emotionally, and physically. So abuse can be more damaging in these early years in the long-term brain development. The influence of the early environment on brain development is long-lasting. It's not that we can't heal children from difficult situations, but we didn't realize 30, 40 years ago how long that damage would continue in a child's life. Early influences are not totally deterministic. Remember, the brain is plasticity of the brain, but it's a predisposition with the strength of their effects on later behavior moderated by a variety of factors. What the intervention is, when the intervention happens, how supportive the intervention is of the particular child's personality, temperament. There's a lot of factors that impact the brain's ability to heal from trauma. Bronfenbrenner is one of the theorists that we look at in this class, and one of the reasons I particularly like Bronfenbrenner is he looks at all of the different ways that a child is affected by their world. And there's more information about his theory in the textbook. But he looks at the child's microsystem. Who are the people in the child's regular everyday life that are impacting how they develop and who they become? And who are the people in the child's exosystem, the neighbors, the school board, the community health and services, the employers of their bosses, friends of the family. All of those people are also having an effect on the child. So all of the classes I teach every semester are in the exosystem of my children. They don't know you, they never meet you, but if I'm doing very well as an instructor and I feel like I'm getting my points across and you're understanding things and things are moving smoothly in my classes, I come home and that relates to how I relate to my children. The same is true for my husband. If work is going well, when he comes home, he has a better relationship with his children. And so that's the way the exosystem works. There's something called the mesosystem, which is the interaction between all the different people in the microsystem. So if the relationship between siblings is difficult, that will impact a third sibling. So we watch the relationships around us to figure out how to build relationships ourselves. The macro system is all the values in society, the laws, the customs of a culture, the subculture. So we look often at the values of the child's culture and also the values of the city, the state, the country where the child is being raised, because all of those are having an impact on the child. And then Bronfenbrenner also talks about this chronos system over here on the right, which is the effect of time. I often think about this as clear overlays on an overhead projector, where one Bronfenbrenner system is done at birth, another one every year or so, and they just layer on top of each other. Some of those impacts from the microsystem or any one of these systems you would see carrying all throughout a child's life. So my mother would carry all the way through my 53 years of life because I'm very close to her and she still has an impact on my life. But my child care provider, Mrs. Welburn, would be down in the bottom layers and had a huge impact on who I am, but isn't actively in my microsystem now. And that's the way the chronos system works. Perception in children are developing very rapidly. Sensory development typically precedes intellectual and motor development. Children are very oral in infancy, and so they explore everything with their mouths. Sensation is a response of sensory systems, eyes, ears, skin, tongue, nose, when it detects a stimulus. So the child's body really is its science lab, and so every single thing an infant picks up, it explores with its mouth, and then eventually with its hands and its feet and everything else. Perception is the mental processing of sensory information when the brain interprets a sensation. From sound to language, if you looked from the left to the right here, hearing occurs in the temporal lobe in both hemispheres, shown here in the green and some of the red parts of the brain. Language comprehension, however, occurs mostly in the left hemisphere, shown here in the brown region. And I think by brown it's more yellow. That responds to known words, and Broca's area, the red bulb here, that produces speech. Children learn the receptive language, what they understand first, before they learn the expressive language. That makes sense. They need to hear words and understand them before they can actually use the words. Infants' brains are especially attuned to their own repeated social experiences and perception that occurs, so they will pick up everything they experience, and they tune into those experiences and look for similar experiences. The infant brain has an auditory capacity to hear sounds in the usual speech range. They're listening for language. They're actively trying to learn language. The parts of the cortex that are dedicated to the senses develop the most rapidly after birth. Hearing develops during the last trimester of pregnancy, which is why you'll hear people putting music on their stomachs during the last trimester. Other parents or grandparents will speak to the womb during the last trimester. The most advanced of the newborn senses at birth, and again, that baby is really programmed to learn language. Speech perception is about 4 months after birth. And so they're tuning into sounds and language, and by 4 months, they're really noticing the difference between speech and other sounds that they hear. Seeing is the least mature sense at birth. Newborns generally can see from the crook of the elbow to the face about 8 inches at birth, and that's the distance while they're being fed of them to their parent. And so it's a logical distance for building social relationships, and then that expands out as they get older. The newborns focus between 4 to 30 inches away. The average is about 8 inches, 12 inches. Experience and maturation of the visual cortex, improves shape recognition and visual scanning and details. Binocular vision, where they can actually use both eyes and bring vision together into one perceived object, occurs at about 3 months. Smell and taste function at birth. Babies have shown a preference for their mother's breast milk. That's how they tested this. They rapidly adapt to the social world. They're related to family and cultural preferences, and they may have an evolutionary function. So babies generally will prefer tastes that their families prefer. Some of this is exposure. When children start to eat finger foods, what foods are they offered? Touch. The sense of touch is very acute in infants, and here you can see Amelia Rose with her mother Jennifer. And that touch of a parent is something that the baby's brain is tuned into. And so their sense of touch receptors are very, very sensitive. Although all newborns respond to being securely held, they soon prefer specific touches of their parents, their caregivers, the people they're closest to. Pain and temperature are often connected to touch. Some people assume that even the fetus can feel pain. Others say that the sense of pain does not mature until months or years later. Many NICU, neonatal intensive care units, have adopted pain and stress-reducing practices because they've noticed pain in babies when they're doing things like the blood test that you see here in the picture. Motor skills are the learned abilities to move some part of the body in actions ranging from a large leap to a flicker of the eyelid. Gross motor skills refer to the physical abilities involving large body movements, walking, crawling, jumping. The course of development, cephalococcal, is head down and proximodistal, center out. Sitting, standing, crawling, walking backward, running, and jumping is the order that children will do those activities. So first they'll sit, then they'll stand, then they'll crawl, then they'll walk backward, then they'll run, then they'll jump. However, children are individuals, and so some will do these in a different order or skip a certain step. My son's friend Kyra, Lori's baby that we talked about earlier in the slide, Kyra Avery from the family above. Kyra didn't walk at all. She didn't crawl at all. My son James crawled very, very quickly. He crawled at about 7-8 months old. And Kyra would point to something and make a sound, and James would crawl over and get it for her and put it in her lap. So she had no need to crawl. There was no motivation to do it. She had somebody doing all that work for her. So at about 10, 11 months old, Kyra pulled up to standing and just started walking. And she skipped the crawling stage altogether. That's unusual, but it does happen. At 8 months, this little girl in the picture is already a adept crawler. She's alternating hands and knees, and she's very intent on what her goal is and where she's going. She'll probably be walking before a year. Some children don't walk until 13 months, 18 months even. My other son, Christopher, didn't walk until he was 13 months old. There's 3 interacting elements underlying motor skills. Children need to have muscle strength, which comes from time on the floor playing. So children that are in swings or climbers or bouncy chairs may not get enough time building their muscle strength. Their brain needs to mature enough to be able to regulate left-right movement and all of the skills needed for that muscle development. And they need practice, which means being out on the floor and pulling up to standing and walking along the side of objects. So children really need a lot of floor time to develop all 3 of those. Most important experiences are perceived with interacting senses and dynamic systems. Sensations facilitate social interaction and comfort. By 6 months, infants are able to coordinate the senses. coordinate what they see with their hand, get that object to the mouth, they can make one thing work with another. And so their brain develops that complexity. Fine motor skills are the physical abilities involved in the small body movements, especially of the hands and fingers, such as drawing and picking up a coin or an object. They're shaped by culture and opportunity. The more opportunity children have to use their fine motor skills, the sooner they will develop. Often children in Western cultures who have a lot of exposure to picking up objects and playing with rattles and things on the floor develop the ability to use sign language before they develop the ability to use verbal language. Sensation motor skills further develop, have 3 goals. One is social interaction. If I can get to an object, if I can point to an object, if I can interact with you by handing you a toy, that will encourage social interaction. Comfort, the ability to move their fist to their mouth and then eventually an object to their mouth so they can suck and self-soothe. And learning about the object, learning about the world. At 6 months, this baby is finally able to grab her toes. From a developmental perspective, this achievement is as significant as walking, as it requires coordination of feet and fingers. Look at her expression and of her determination and concentration as she's figuring this out in that photo. All healthy infants develop skills in the same sequence, but the age of acquisition varies. It depends on genes, cultural patterns, nutrition, and caregiving patterns. How often is the child put on the floor to wiggle and crawl? Difference is not deficit. Slow development is relative to local norms. It may indicate a problem that needs attention, but we may not know that till later. Some children, like the example of James and Kyra, will develop sooner or later those same skills. So there's certain windows that they talk about in your book where we may want to make a referral, but not all children do things at the same age. There are some characteristics of development, so remember plasticity. It's the idea that abilities and personality and other human traits can change over time. Plasticity is particularly evident during childhood, but even older adults are not always set in their ways. We can always change. Our brain is always adapting and growing. Both the universal and the unique are evident in every single developing person. So we are the same and we are different than everyone else. We are unique selves, but we have a lot of similarities as well. Sociocultural theory, which we'll look about later in class, is development results from the dynamic interaction between each person and their surrounding social and cultural forces. So next week we'll get into more information about sociocultural theory. It really looks at the nature-nurture debate. Nature refers to the influence of genes. Remember, we talked about that in biology, DNA. Nurture refers to the environmental influences. The nature-nurture controversy has many other names: heredity versus environment, maturation versus learning. The basic question is how much of any characteristic, behavior, or pattern of development is the result of genes and how much is the result of experience. And so we don't really have quick, easy answers for that. It's the biggest conversation we have in our field. Magda Gerber is a wonderful theorist, philosopher about how best to work with infants and toddlers. So there's a link here that I'll put into the module this week. We're going to be moving on to your toddler observation assignment this week. And so there's really good videos out there about how toddlers develop, about how to work with infants and toddlers. And so I'll put that link into this week's module. When we start our observations, I wanted to start you with a quote about observing. I want you really to open your eyes and put everything you thought you knew to the side while you're observing. To acquire knowledge, one must study, but to acquire wisdom, one must observe. It's one of my favorite quotes about observation. Why do we want to observe children? We want to measure their learning by age, development, where do they need help, possibly to make a referral. We want to get to know the child. We want to find out their interests, check for signs of trauma or issues. We might want to observe them to understand their behavior. Behavioral assessments are done first with observations. Curriculum planning is usually based on the emergent interest of children that we get through observations. Developmental assessments are done on all children based on our observations. We share stories with families and other teachers based on our observations. And it helps to build our relationships when we share our observations of children. We want to make sure to do this with reflective observation, where we're observing objectively, getting the details, and then really reflecting on what does this mean, which is the purpose of this assignment. Steps for teachers: we want to observe, record, collect data. That's very objective when we're doing that part. Then we analyze the data for trends. For that, you'll be doing your paper, and more information about that will be in your assignment. Then we prescribe solutions, curriculum responses. Main principles of observations are not principles of diagnosis. It's just something we want to understand. Sometimes you need to look at life from a different perspective, and that's the purpose of observation. We want to be detailed, get as many descriptive details in there as we can, make sure we can picture what you're seeing. The more details you put in there, the better we can see what you see. We want to be objective, make sure that we are using language that is non-judgmental, that is open to interpretation. So rather than saying a child is happy, we might want to say that they're smiling and allow the reader to make that interpretation. This is an example of an observation that's not objective. Daria moves to the art table, skipping happily. She grabs the scissors from Joseph aggressively and screams, "These are mine!" The teacher is not paying attention and ignores Daria. Daria moves towards another chair and happily sits down to cut paper, singing to herself. The teacher continues to neglect Daria and Joseph, who has moved to another area. So you can see some of the words that make this not objective. Happily, grabs, aggressively, screams. Not the teacher's not paying attention, ignores. All of those are words that are charged, and you might read this and think, I don't want Daria in my classroom. I don't want to hire that teacher. We want to teach Joseph to stick up for himself. You might think any one of those things from reading this observation. So look at the rewrite and see what you think. Daria moves to the art table, skipping and smiling. She reaches over to the scissors in Joseph's hands with her right hand. She takes the scissors out of his hand and says loudly, "These are mine." The teacher does not respond to Daria. Daria moves towards another chair and sits down. She uses her right hand to cut, turning the scissors both directions, left and right. Small shapes fall from the paper as she cuts. She is singing softly. Joseph stands up and moves to another area. So think about how your perceptions changed of Daria, of the teacher, of Joseph. The objectivity gives us a chance to find other possible interpretations for what we saw. So I want you to pause the video at the next slide. There'll be a photo. Time yourself for 3 minutes as you look at the photo and take notes about everything you see. Try and be detailed and objective. And when you're done, we'll come back. So as soon as you see the photo, hit pause and then get a timer. So if you've paused for 3 minutes and restarted the photo, take a look at your notes and now look at the photo very closely and see what details did you get. Pay attention to what you may have not been objective about. Did you notice the two girls up here, or I assume they're girls, I actually don't know, that wasn't objective. The two children here with their heads leaning in towards each other. Both of their hands are doing the same motion. There's one child standing off at the back here, not at the activity and not appearing by her feet to be moving forward. There are two other children standing at the back. They're both gazing towards the puddle, but not actually doing anything. What of the details here did you get? Which of them didn't you get? This is a chance to practice that observation. I encourage you to find videos on YouTube. Observation videos there's a lot of them out there, and you can practice doing these observations there before you do your assignment. If you want me to look over a couple paragraphs and say this is objective, this is not, I can help you with that if you're concerned, or you can ask each other as classmates. I'll put a little of practice of that in our discussion as well. So there's a video here that I'll also link in this module about observations from first 5. What's the purpose of them? Remember, if you want to, this is from Magda Gerber, if you would record the growing and learning, you must record what they do with their bodies. Watch their hands, watch their feet. Their facial expressions will tell you a lot about what they're learning and what they're doing. Make sure to review the assignment on Canvas and ask me questions as you go. I will be online this week, and there will be a new assignment questions discussion opened up specifically for the toddler observation. You will be doing your observation at Mission College for the toddler observation assignment. If for some reason you need an exception to do it somewhere else, please message me in inbox on Canvas, and I will talk to you there about making an exception. I'll be making a video tomorrow afternoon when I get back to Mission. I had to go out of town unexpectedly this weekend, so couldn't get to the college to make the video. I will do it tomorrow afternoon, and I'll show you the picture of the computer where you sign in and how to do that. And I'll also give you the code in that video. You're going to sign in on that computer outside of the doors, and then make sure before you go in that you turn off your cell phones while you're in the observation rooms. There's absolutely no photos or videos allowed while you're observing. You should get a pen and paper or a computer if you want to type, and type your notes or write your notes as you're observing. In the observation room, please be as quiet as possible. Sound carries through the vents. Avoid conversation, rustling of papers, notebooks. Children's photos with first name, age, and daily schedule are on the wall in the observation room, so you should be able to find those there. Write up your notes as soon as possible after doing the observation. You will get more details from rewriting those notes immediately. So try and do that as soon as you can. Please don't ask questions or interact with parents or children in the halls or classrooms. They really deserve to just be able to drop off their children and talk to their teachers. They're not there to answer questions. If you have questions, you can direct them to Karen Navarro, who's the Children's Center Director. She's in the preschool building. Or Idalia Gomez, who's the program specialist in the reception area of the infant and toddler building. And again, I'll have a video tomorrow to show you more of that. Remember that absolutely everything you observed needs to be kept confidential. These children are there for you to observe because it is a lab school, but their stories should only be used for your paper and here in class and discussions, and absolutely not discussed anywhere else. That confidentiality is critical for the children and their families. And you'd be surprised, you may be talking to your friend at the cafeteria after doing your observation. It could be the best friend of the parent who's sitting behind you, and they recognize the story you're telling, and you've already broken confidentiality. So please do not talk about these observations or share them with anyone else. If you have questions, please go out to the discussion for the questions, and I will see you online. Thank you.